All right, welcome back. This is week 9 and chapter 9. We're still looking at combustion and boiler control. So this is very essential to have the proper control, understand how do we control the burner and how do we have a proper combustion control in a power plant. So we'll talk about the steps burner management system goes through when starting a burner, what are the steps and why, and how did that get automated over the time. Describe the operation of on and off, high and low, off control. This is very relatively easy. And describe the operation of modulating controls and the two types of positioning controls. We'll talk about that as well. Describe the operation of metering control system. By metering, we are trying to measure either the fuel coming in or the steam coming out. And different type of control signals. What does it mean? Analog, digital, and so forth. So let me just start by saying, there was a time when the boiler room had to be completely manned with somebody who will control the fuel, somebody who will measure the gas, and there was a lot of manpower involved in the control room. Now things are more automated. There are more system control that things will work by themselves, and there's a lot of sensors, so it's easier to have the power plant running on cruise control, kind of like a car, with least monitoring possible. However, we still need to have somebody to be live in the control room to monitor what's happening. But as we advance with control, we can do everything automated remotely. However, for emergencies, somebody always has to be in the control room, at least one, from what I know. And depending on the size of the power plant, you might need more than one person. So most of those controls, this is relatively new. If you think 10 years is new, some of the companies produce like FireEye or Honeywell. They have major controls. What do they control? So if you take combustion control circuit, we'll talk about the sensors of the control. If we go back to the main equation again, for combustion, we have fuel plus air plus ignition. We have heat plus water plus CO2. Okay, so what we are putting in is air, fuel, the ignition just in the beginning, then it goes away. So at the end, let's say will stop after we have the fire. The fuel and air is what we're putting into the boiler. And we're getting out heat. What is the heat producing? Steam. What is the CO2 an indication of? Combustion. This is how we monitor the combustion, and this is how we monitor the output, is the heat. So the burner will tell you what's happening and what are the steps. So what stage are we in? And there are some processes that has been developed as a best practice for how do we start a boiler. Of course, it's way more involved than the way we will describe it here, but as you get exposed to it, you'll understand how it works. So this module will tell you what's happening. This is kind of, as I said, relatively new and old at the same time. You'll see it in the field, but now there's a lot of LCDs which tell you in more details and give you more intricate messages. So what happens? So the first thing we do is want to verify. Let's look at the steps. We have a boiler. Let's say it's coming up from being not functioning for like the night or the day. So a gas pressure improving switch, which first thing we want to know, do we have fuel or we do not have fuel? So we can put a sensor in the gas fuel to know that we have fuel. We want to have sensors to see what's inside the chamber, what kind of fuel is coming, how much oxygen is in the air, what is the temperature of the air, because that will determine how much oxygen is in there. So we want to know that actually we have gas pressure, otherwise there's no point of starting the boiler. Then, let's say we know that we have gas coming into the line, so we can start. an ignition transformer that will provide a spark that we need for the ignition. And usually in large boilers, we don't light the main flame. So we have small flame with a spark, then we have the big flame. For the small flame, it's called the pilot. The pilot gets lighted up by the ignition transformer. It's the igniter, and it's the gas line. So we light the pilot, make sure we have fuel, we light the pilot. Again, it's very, very oversimplified. So a flame scanner will tell you that, okay, the pilot, what's a flame scanner? There are many types of flame scanners, probably you can see in the book. Basically it tells you that, okay, there is flame inside the chamber. Because sometimes it's not really easy to see inside the chamber. So you look at the pilot light and it will tell you, okay, there is some pilot light, we're good. There's fire inside the boiler, but it's not the main fuel. After we prove there is fire inside, we go to the main fuel. Okay, here are the examples of the scanners. So these instrument usually verify that there is fire inside the chamber. One of them is infrared. So fire produces, let's talk about that a little bit. Components of fire. So if we have a fire, and I put some flames in here. Okay, this is my flame. So we'll have light. We have, and the light also have many things. We have visible light. We have ultraviolet, UV, and we have infrared, and we also have ions, and we also have heat. So all this is a product of fire. So the sensor here, the infrared sensor, will sense the infrared from the fire. UV does the same thing. It can sense the ultraviolet. Photocells will react to the visible light. And finally, we have something called a flame rod, which will react to the ions of the light. So sometimes we have more than one of those things to just prove the fire and know how much fire we got in there. And sometimes we want to have some kind of redundancy. So they work all together, and they are connected to the big control system that we saw before to tell you, okay, we did the pilot, now we have some flame. This is a really important table to look at. This is the fuel application. For flame rod, we have gas. Why do we have different fuel with different sensors? Every fuel burns differently at different temperature and produce different lights. Some sensors are more sensitive to others than other sensors. Signals, what signal do they send to the controller? DC, which means direct current. Again, if we took current control, probably understand the difference between DC and AC. So this is how we try to get a signal. DC current for most of them, and infrared uses AC current. And again, it's not always the default. Different sensors have different reaction, different controller have different response. So, but this gives you a very good picture of what's happening inside the flame sensor. So the flame scanner is used to prove a flame. Some of them can react with natural light. Some of them require to have actual flame, because as we said, it's not natural light. We see here, it has to be actual fire, because we are reacting to heat. These lights do not produce a lot of heat. UV and infrared are also something that we have to sense. So after the programmer proves that the main flame, so after we do the pilot, we release the main flame. The main flame will come, and then we go into cruise control. So okay, we have the flame, main flame now is proven, so we will go on and let the whole thing in control. So these are the main steps. So first one here is pre-purge. I'll explain what that means. Then pilot flame. 3, main flame. 4, automatic control. Which is normal operation. And 5 is post purge. These are the 5 elements that you will see in a control module. So the first thing is the pre-purge. The pre-purge is when we turn on the venter. We like to open this the fan and release and dispense of all the gases inside the chamber. Why? We don't want any residual cold air or fumes from the last burn. So we try to get everything outside. That's the pre-purge stage, and that depends a lot on the size of the chamber, and probably the book has more elaboration in that. But a pre-purge is the first stage. Then we have the pilot flame, which we talked about, where we establish that there is some small flame inside the chamber. Then we go to the main flame. The main flame is the main purpose of the whole operation. We lit the right flame, we have the right flame is there, we are producing heat, we're good. Then we go on cruise control, which is the automatic control. We let the whole thing run, and we have upper limit and lower limit for steam. We control the flame as we go, based on the steam coming out. Once we shut off the boiler, we go to post-purge, which means again we try to dispense of all the heat and all the gases inside the burner. So this is the combustion system. So now with this flame, probably you'll see this kind of control in a control room or in an LCD by the control system, where this is the flame. This is how much stack we have of flue airs, and these are the pressures, and this is how much flame we're pumping inside. So there's a lot of information that can be seen from here, and probably there's always an alarm. If you look here, there's a smaller little alarm that tells you, oh, the pressure is too high, the pressure is too low, the fuel is too rich, so on and so forth. So there's a lot of input for you to know if the combustion is going correctly or not. So we did that again, automatic control. Oh, no, going back, sorry. So here, steam pressure is used by the plant master to determine the firing rate. So the whole purpose of us firing this big steam boiler is to produce steam, because we want to produce power. So this is my goal. The turbine needs some steam to run, so I want to have whatever amount of steam I need. So based on the steam output, I will control how much is my firing rate, and that is controlled by the fuel and air. Again, for example, I will use the car again. Cruise control. You go on the highway, you put the cruise control on 65. The car knows that it wants 65. If you go downhill, it will cut off the gas and the air, and the car will go slower. If you go uphill, it will increase the gas, the firing rate. So the output for us here is the steam, and for the car is the speed. On and off control, that's really very common, is when we try to control the speed by, if this is my set point, I'm going to go on and off, on and off. I'm going to turn off the boiler and turn on the boiler to control the steam. This is very old, and there's a lot of losses because we're going to keep going up and down. It's very simple, but it's not very efficient, because again, this is my set point. I want to be in the middle, but I'm going up and down, and it will average out to be in the middle. Now you have something that has more control. Like I want to modulate properly, so I have the right speed at the right RPM, talking about the car again, without having to go on and off. So imagine if you're going in a car and try to maintain 70 miles per hour, 60 miles per hour, and you're hitting the gas, and you go from 50 to 70, 50 to 70 to be 60. That is very not practical. There are some manual resets and shutdowns. Those are also for overrides if something goes wrong. But mostly with a lot of newer controls, it's more modulated, and it's more where you want it to be. Pressure control. So now we have, again, we want something linear. Remember what we talked about, the up and down? We want something linear response. We want something that will control the dampers, we control the fuel. So we have the right amount of fuel ratio and the burning rate, so we can achieve having the proper amount of steam without having to go on and off. This is the whole point of having those dampers. And again, think of the cruise control inside the car. Single point and double point, don't worry about that too much. It's basically trying to tell you that we can control the fuel or the air, and the air then the fuel. But for the new ones, there's a damper motor that will control both of them. So in the car, you don't control the air, you just control the fuel, and the air is connected to the fuel. So the same thing is happening here. We control the fuel, and the air will follow. Back in the days when you used to have carburetors, you'll have to balance the fuel, the air based on the atmosphere. Now there are sensors in the car that will tell you this air is rich in oxygen or has less oxygen, so the fuel will adjust by itself. So this is the single and parallel. Basically they are controlled together. Don't worry too much about that. Just so you know it's not single point. Single point is you control the fuel and the fuel control the air. Parallel is when you control both the air and the fuel together. So for control, again, that's also depending on the gas properties and the fuel. So if the gas is has more BTUs than it's supposed to, or the fuel oil is more viscous, this will control the heat again based on the output. So based on the steam, we can control the amount of fuel or control the amount of air that's coming inside. For metering is more specific when it comes to coal, because again with fuel, if the fuel is the same property and it's very consistent, we can know how much heat we can get out of it. Same thing with oil. But with coal, it's a little bit tricky because again, coal is not as consistent as oil. So we need some kind of metering that will tell you how much weight of coal you have to put in there. And based on the firing rate, maybe we can increase the flow of coal inside the burner or not. Oxygen trim strategy. That is, again, in some plants, depending on the weather. So cold air will have more oxygen because it's denser air than hot air. So these oxygen trim sensors will sense the air coming inside the boiler and will tell the controller whether we should pump less fuel or more fuel to achieve the proper amount of temperature. It's very, very vital to have one of these in boilers, just like how you have oxygen sensors in your car. You probably noticed that the car will perform the same whether it's winter or summer, regardless of the temperature. And that's because we have now oxygen sensors that will sense how much oxygen coming into the air. Variable speed, we talked about that in the second week, which very useful technology that we have where we can vary the speed of the motor without having to turn it on and off. We can use that by increasing and decreasing the voltage and having a different variable speed motor. So all in all the data, we have input, we have output, and we have a control that will monitor the process and will tell you what is going on and will give you a message. Again, these days probably all cars have computers. The computers do a self-check in your car and tell you, okay, there's something wrong with the brake, there's something wrong with the oil level. So these are all inputs. How do you think those cars go with those inputs? There are many sensors in your car that send an input to a computer in your car, and that computer can either send you a message or sometimes just turn the check engine light, and you go to a mechanic and he will plug in the scanner and you will find the code. Similar thing happens here. We have many codes, we have many sensors, and the plant is much bigger, but it's the same concept. We have a controller that depends on a lot of sensors, and those sensors will send you input. And based on that input, we expect some kind of output. If that output is not met, then an error message will come, and you have to clarify what is happening in the controller. That concludes the PowerPoint. For the study book, there's the gas flow correction. I want you to read through this, the gas flow correction, and try to see if it makes sense to you. And it basically goes through the ideal gas flow and how do we correct the amount of the volume coming into the boiler based on the temperature and pressure. So try to just focus on 9.1, which is the gas flow correction, and let me know if there's any questions regarding that example. And if you can please just go through the questions in the study guide and also in the end of the book for the homework. All right, thank you and see you next week.